For the word problems, we use the basic function of exponential growth or exponential decay, depending on the situation. The basic function is, a of t equals a, parentheses 1 plus r to the t power. A is the initial amount, basically the starting amount. A is the starting amount. R is the percent. Remember, percent should be written as decimals. And T is going to be time. With most of these exponential growth models, we are not going to do T-charts. We're going to have you use Desmos.com to graph them, and then you would sketch the graph on a coordinate plane. So I'll kind of explain exactly what we do on this one. So if you look at number 7, it says a virus spreads through the network of computers such that each minute, 25% more computers are infected. If the virus began at only one computer, graph the function for the first hour of the spread of the virus. So using the basic formula that's written above, A of t equals a1 plus r to the t power, our function would be, the initial amount is what A is, and it just said a virus. It doesn't say how many viruses it is. It just says a virus, A meaning 1, so A is going to be 1 times the quantity of 1 plus, the rate's 25%. We need to write that as a decimal. 25% as a decimal is 0.25 to the t power. And if I simplify what's in parentheses, it gives me 1 times 1.25 to the t power. Okay? Then you would go to Desmos. Now, I don't have Desmos on my iPad, what I'm recording this on. I have another one. It's called EduCalc. And on EduCalc, let's see, I got to delete this real quick. This is the way I use it. Desmos is a little bit different. So our equation was 1 parentheses 1.25 close parentheses to the, there's the caret button for the exponent, to the t power, or in this case, since I don't have a t, I have to use an x. And this is what the graph looks like. So it looks like I've got to zoom in a little bit because I was zoomed so far out while ago. There we go. It looks a little bit better. Getting closer. Oop, too far. There we go. So this is roughly what the graph looks like. So you can see at 0 minutes, right here. I don't know if you can actually see me poking on it. At 0 minutes, it is at virus of 1, but as we move to the right, you can see after 4 minutes, if you go up to the graph after 4 minutes, then it's going to be approximately a little over 2 viruses. After 10 minutes, you can see how fast it's increasing. So when I go up to 10 minutes, you can see that if I go to the left, you can see where that point is at 10, about 9. So after 10 minutes, there's 9 viruses. So what you would do is you would figure out the equation, you would sketch it on Desmos, and then you would draw a graph to show me that you sketched it. So that's how you would do that one. And then the last one, financial literacy. A new SUV depreciates in value each year by a factor of 15%. Draw a graph of the SUV's value for the first 20 years after initial purchase. And over here it tells you the price of that SUV. The price of the SUV is only $30,000. So that's our initial amount. So it's going to be A of t equals 30,000 equals 30,000 times the quantity of 1. Now this time it's depreciation. Depreciation means it's losing value. So we're actually going to subtract the rate of 15% to the t power. So that would be 30,000. 1 minus 0.15 is 0.85 to the t power. So that is your function. Now I would go to Desmos, and I would type that in. So it was 30,000, parentheses, 0.85 to the t or x power. I'll use my caret here. Save it, graph it, and you can see, since I got to show the first 20 years, which is what the x value indicates, I'm going to have to go up really, really, really high to find that $30,000 starting point. So it's going to cross the y-axis at 30,000. There you go. You can see where it crosses the y-axis at 30,000. And then it depreciates rather quickly. So if I zoom in on just the x-axis, so it starts at 30,000. By the time it gets to 5 years, the value of that SUV is just not much over $10,000. And by the time you get to 10 years, the value of that SUV is just about $6,000. So you see the value of a vehicle depreciates very, very quickly.